Good morning all. Our today's session is on simplex model. Here I have mentioned the procedure for simplex model. This condition is important for simplex model. When decision variables are more than 2 and if all the constraints are less than or equal to, then we will use simplex method. That is very simple. Slack variables. Suppose constraints are less than or equal to. Here less than or equal to or greater than or equal to constraints, we need to convert it into equality. The slack variables represent unused resources S1, S2, S3, S4, etc. Variables are slack variables. A slack variables contributes nothing to the objective functions, means here coefficients of those slack variables will be 0. That is the meaning of this sentence. Surplus variables. Suppose constraint is greater than or equal to. This constraint we have to convert it into equality. Here we will add surplus, that is artificial variable we have to add. Same thing will be for objective function. Next is basic solution and second one is basic feasible solution. Initially we will find out basic solution. Next, basic feasible solutions are to satisfy the non-negativity condition. There are two types, degenerate and non-degenerate. These things we will discuss in problems. First problem, objective function will be given like this and some constraints subject to the constraints for this objective. If you are trying to satisfy this objective, here we have to follow these constraints. These are the limitations given. Here all constraints are less than or equal to. Here all constraints are less than or equal to. And this condition is important. This should be non-negativity. Solution. Step 1. Convert all constraint equation into equality. 4x1 plus 5x2 plus s1. Here constraint is less than or equal to. Here we have to add s1 slack variable. Similarly for second equation, third equation, and this condition is required. Second step, one feasible solution that satisfies all the constraints. Here we will add some variables in objective function. Here z minus 13x1 that is given here equal to 0. These things we are calculated by putting x1 and x2 equal to 0 in above equations. S1, S2, S3 are basic variables now in step 2. Step 3. These equations, standard converted equations we have mentioned here. Their coefficients we have mentioned. Coefficients of variables which are given in equations. x1, x2, s1 variables. Here basic variables first column and coefficients of variables are arranged like this. Solution column and ratio. Next is, this is our objective function. Here we have written all coefficients of objective function. Then s1 equation, s2 equation and s3 equation. Here I am calling this is s1 equation, s2 equation and s3 equation. Here we have added slack variables. These things are arranged according to the given equations. Here step 4 is, this step is important. Choose the most negative number from Z row. In Z row most negative is minus 13. We can select that column is entering variable column. And in ratio, here we have to take ratio 1500 divided by 4. That is ratio. Similarly for 1575 divided by 5, then 420 divided by 1. These are the ratios. These are the least ratios. Out of these, we have to select least one. Out of these 3 ratios, this one is least. 315 is least. Then key point or key element is 5. Calculate ratio. that is already we are calculated. Each and everything is mentioned clear. Here our leaving variable is S2. This is our leaving variable row and this is our entering variable column. Means X1 is coming and S2 is removing. Our leaving. Next step 5. X1 becomes basic variable and S2 becomes non-basic variable. These variables are basic variables and these variables are non-basic variables. Here we will see x1, x2, x3 or some other variables. These variables will be basic variables. Here same thing I have mentioned, entering variable and leaving variable. Here I have calculated these elements. Then how to calculate these elements? I have mentioned here this procedure or one formula. Old element minus intersectional element of the entering variable column in the respective row into current element of the replaced row in respective columns. Here I have calculated this one. Here equal to minus 11 that is given in previous, that is minus 11 minus 13 that is also given here, that is our entering variable column. Then into 3 by 5 that is ratio, this is replacing row in previous step, this is replacing row 3 by 5 that is ratio. Here you will get value this one. Similarly for all elements. Then next step we have to repeat this step up to the optimum solution. Next step here is, here our entering variable most negative value is minus 16 by 5. Here we can enter, we can select this column, and leaving variable is this one, because out of these three ratios least one is 75. That's why it is leaving variable. S2 is leaving and X2 is entering instead of this X2 and X1 and S1. Next step, next table. After these calculations you will get this table, and here we can observe, here all values should be 0 or less than 0. It means it is an optimum solution. Hence our optimum solution is Z max. Here our objective function is max or minimize. Here we can cross check. Here our objective function is max Z, it means Z max. Here Z max equal to this one. Then S1 is not required. X1 is 270, same thing is written here, and X2 is here 75. That is our final solution. Then you will get complete marks if your solution steps are like this. Second problem, maximization case. Same case, same thing. Here all constraints are less than or equal to. Don't get confused. Here I have converted these equations into a standard form, inequality form, by adding S1 and S2 variables. Similarly, we will arrange these coefficients in tabular form. Here I have mentioned steps. X2 is the entering variable because most negative is minus 5. S1 is the leaving variable. S1 is leaving variable because ratio is least 8 by 3. The ratio is least. Similarly for this one, X3 is entering variable and S2 is leaving variable. Here S2 is leaving variable because ratio is least and here is most negative. You have to do calculations for all elements by using last formula. Similarly for this table, most negative is this one, X1 is entering variable and leaving is S3. This is our least positive ratio. Least positive ratio is important during the selection of leaving variable. This is our optimum solution. Here our optimum solution. Here our objective function was Z max. Z max equal to 765. 765 divided by 41. X1 is 89 by 41 and X2 is 50 by 41. X3 is 62 by 41. Problem 3. Here case is minimization. Here we have to do some changes. Here we have to convert this minimization case into maximization case. After that, rest of the procedure is same. Here we will convert maximize case. means all values will be negative. Here x1 is positive, here negative, then positive, then negative. Here case is now maximization case. After that we will convert it into standard form. These are the standard forms, initial, basic, feasible solution, and after that procedure is same for all steps. Here I have mentioned all steps very clear. This is our optimum solution. These are the solutions. Here I have mentioned special case, that is unbounded solution. Here this is our problem. Here we will convert it into standard form, that is initial, basic, feasible solution for this particular problem. This is our tabular form. Here I have mentioned this step. Next, this is our unbounded solution. If your all solutions or all variables are negative or ratios are negative, that is our unbounded solution. Your ratio should be least positive. Then we will proceed for next step. Otherwise, don't proceed. That will be our unbounded solution. Thank you.